Now we're in chapter 3.3 and it's on the addition rule. Our objectives: determine if two events are mutually exclusive and use the addition rule to find the probability of two events. Mutually exclusive. Two events A and B cannot occur at the same time. That is what it means to be mutually exclusive. The two events cannot occur at the same time. The figure on the left is a Venn diagram representing two events. This is event A, and over here is event B. And you see they have no overlap, therefore they are not happening at the same time, so events A and B are mutually exclusive. On the second, to the right, we have event A, and we have event B, and we see that they overlap in the middle, therefore they are not mutually exclusive. It says the addition rule. So the addition rule of probability of A or B. The probability that event A or B will occur is equal to the following. It's the probability of A plus the probability of B minus the probability of A and B. This and means the intersection or the overlap. Realize that by adding the probability of A plus the probability of B, you've actually double counted. That's why you have to subtract out A and B. If your events are mutually exclusive, then the rule is simplified. It's just the probability of A plus the probability of B. I'm going to go back a slide. When events are mutually exclusive, there is no intersection, or basically no overlap. So what are you subtracting out? It's really 0. Therefore, you can just ignore that. And it's simplified just to be a probability of A plus the probability of B. That's only if your events are mutually exclusive. Otherwise, you have to subtract out the overlap. And for mutually exclusive events, this definition can be extended. So let's say I have the probability of A or B or C. Well, that's the probability of A plus the probability of B plus the probability of C. And that's only if A, B, and C are mutually exclusive. All right, let's go in our books to page 162 actually. And we're going to look at numbers 9, 11, 13, 16, 17, and hopefully number 23. So let me write these down just in case you want to start early. 9, 11, 13, 16, 17, and 23. Let's start with number 9. It says, determine whether the events are mutually exclusive. Explain your reasoning. And number 9 says, event A, randomly select a female public school teacher. Event B, randomly select a public school teacher who is 25 years old. Well, these events are not mutually exclusive because we could have a public school teacher who is female as well as 25 years old. So event A was a female teacher. And event B was a teacher who is 25 years old. Well, can we have a female teacher who's 25 years old? The answer is yes. Therefore, these are not mutually exclusive. They can occur at the same time. All right, number 11. And it says, event A is randomly select a person who is Republican. Event B, randomly select a person who is Democrat. So A is a Republican. B is a Democrat. Well, can these events occur at the same time? can you have a Republican who is a Democrat? Or can you have a Democrat who is a Republican? The answer is no, therefore these events are mutually exclusive. Number 13. A biology class has 32 students. Of these, 10 students are biology majors and 14 students are male. Of the biology majors, 4 are male. Find the probability that a randomly selected student is male or a biology major. So let's write down everything they gave us. So I know the class has a total of 32 students. I know 10 of the students are biology majors. And I also know 14 of them are males. And then they say, of the biology majors, 4 are males. So the ones that are male and biology major, that's equal to 4. Then it says, find the probability that a randomly selected student is male or a biology major. So this is the probability of male or biology major. So remember how we did it? It was the probability of the male plus the probability of the biology major minus the overlap. So the probability of male and biology major. Well, the probability of a male, well, how many males were there? There was 14. So that's 14 out of 32. Plus, how many biology majors? There were 10 out of 32. Remember, it's a probability, so don't forget to divide by the whole or the total. Minus, what was the overlap? 4 out of 32. So this becomes 20 out of 32, which is approximately 0.625. All right, number 16. And it says, of the cans produced by a company, 96% do not have a puncture. 93% do not have a smashed edge, and 89.3% do not have a puncture and do not have a smashed edge. Find the probability that a randomly selected can does not have a puncture or does not have a smashed edge. So let's write down the information again. So let's see. 96% do not have a puncture, so no puncture. That's 96%. 93% do not have a smashed edge, so no smashed edge. 93%. And then 89.3% do not have a puncture and do not have a smashed edge. I'm going to write it as no puncture and no smashed edge. And that was 89.3%. And it wants us to find the probability of a puncture or a smashed edge. So the probability, it does not have a puncture or does not have a smashed edge. Well, remember, that's equal to the probability of do not having a puncture plus the probability of not having a smashed edge minus the overlap. So the probability of not having a puncture, well, that's 0.96. See the percent? Go ahead and change it to a decimal. Plus the probability of not having a smashed edge, 0.93. Minus their overlap, which was 0.893. Add these and subtract the last number, and that comes out to be approximately 0.997. So add the two probabilities separately and then subtract their overlap. Okay, number 17. It says a card is selected at random from a standard deck of 52 playing cards. Find each probability. Part A. It says randomly select a club or a 3. So this is the probability of a club or a 3. Well, that's equal to the probability of a club. Well, there's 52 cards total in the deck. How many of them are clubs? 13 of them, so it's 13 out of 52. Plus the probability of getting a 3. Again, 52 cards in your deck. How many of them are 3s? 4. Minus the overlap. So you want to know how many cards in your deck are 3 and a club. So a club, that's a 3. There's only 1. So that's 1 out of 52. And this is approximately, let's get our calculators. And we get 0.308. All right, part B. And it says randomly selecting a red suit or a king. So the probability of a red suit or a king. So we're going to do the same thing. Find the probability of a red card. We'll total 52 cards in the deck. 26 of them are red. Those include the hearts and the diamonds. Plus the probability of getting a king. Well, again, 52 cards in the deck. There are 4 kings. Minus the overlap. So you want to know how many cards in your deck are king and red. Well, that will be the king of hearts and the king of diamonds. So it's 2 out of 52. And again, let's calculate this. We get 0.538. And part C says randomly selecting a 9 or a face card. So the probability of selecting a 9 or a face card. Well, we know our formula. So probability of a 9. There are 52 cards in your deck. 4 of them are 9s, so that's 4 out of 52. Plus the probability of getting a face card. Well, let's see. How many face cards are there? They will include the jack, the queen, and the king. These are face cards. Your jack, your queen, and your king. So there's 3 face cards per suit. So you have a jack, a queen, and a king. That's from hearts, diamonds, your clubs, and your spades. So there are a total of 12 face cards in your deck. So that's 12 out of 52. Minus, now we need the overlap. How many face cards are 9s? Well, if you were listening, we just said that jack, queen, and king are the face cards. Therefore, there are no face cards that are 9, so we're just subtracting out 0. And then we can go ahead and use our calculators and we can approximate this. And we get 0.308. All right, last one, let's look at number 23. And it says, the table shows the number of male and female students enrolled in nursing at the University of Oklahoma Health Sciences Center for a recent semester. A student is selected at random. Find the probability of each event. So we have a table in front of us. And it says, part A, the student is male or a nursing major. So let's see here. The probability, the student is male or a nursing major. Sorry, my pen's messing up. Let's see if we can make it through. Well, first thing we're going to do is find the probability of a male. So up here is the probability of getting a male. Well, how many total people were surveyed? Look in the bottom right corner of your table and you'll see 3,605. Okay, so of that 3,605, how many of them were male? Is 1,198. 1,198 plus the probability of a nursing major. Again, we have a total of 3,605 students being surveyed. How many of them are nursing majors? 819. To find the total nursing majors, find the nursing major column, go all the way to the bottom, and you'll see the total is 819. To find the total males, find the row that has males, go all the way to the right, and you'll see the total is 1,098. Now we need to subtract out the overlap. I'm running out of room. Let's see if I can make it. Oh, we might be able to. Let's try. So this time we're going to subtract out male and nursing majors. So again, 3,605 students were surveyed. Now we need to know how many of them were male and nursing majors. So I'm going to draw a part of the table so we can see what I'm talking about. Okay, the word and means that they run into each other. They're an intersection or they overlap. You see, when you look on your table, where does males and nursing majors run into each other? At the 94. So you're subtracting out 94. And this comes out to be approximately 0.533. All right, let's look at part B. It says the probability the student is female or not a nursing major. So you want the probability of female or not a nursing major. So the probability of female or not a nursing major. Well, again, we got to find the probability of female first. 3,600 students surveyed, 6,005 students surveyed. 3,605 students surveyed. Let's find out how many were females. So find the female row, go all the way over to the right, and the total is 2,407. So the probability, again, the female is the following, plus the probability of not a nursing major. Well, again, 3,605 students surveyed. Of them, how many of them were non-nursing majors? 2,786. Minus, again, the overlap. So you find where females and nursing majors overlap, basically run into each other, and you'll see it's 1,682 over 3,605, and this is approximately 0.974. And then last one, part C. And it says the student is not female or is a nursing major. So the probability the student is not female or is a nursing major. Well, if you're not female, you were technically then male. So this is saying the probability of male or nursing major, which is the same as what we did in part A, so the answer should be 0.533. Alright, so here's a summary of what we did in 3.3. Please email me if you have any questions.